Hello students, welcome to my channel. Today in this video we are going to learn our first chapter, real numbers. So real numbers, already you have an idea about real number, right? So what is real number? Real numbers are nothing but rational numbers and irrational numbers combinedly called as real numbers, right? Rational and irrational numbers commonly known as real numbers. So again, what is rational number? Rational number is a number which can be written in the form of p by q, that is numerator by denominator, and here q not equals to 0. Okay, so these are called rational. And coming to irrational numbers cannot be written in the form of p by q. Okay, right. So here in the rational numbers you have integers. Integers means, what are integers? Integers are denoted by z. Integers are negative numbers, 0 and positive numbers. Okay, and again a part of integers, 0 and these positive numbers are called whole numbers, right? So whole numbers, 0 and positive numbers are whole numbers. Again, part of these whole numbers without 0 or these counting numbers are natural numbers. So counting numbers are called natural numbers. So, and here coming to irrational numbers, non-perfect or simply prime numbers in square root, and non-terminating and non-recurring. You have learned in your 9th class already about these rational and irrational. Okay, so what are real numbers means rational and irrational numbers commonly combinedly known as real numbers. Okay, again, what is rational? Rational means the number which can be written in p by q form. That means every integer, every whole number, every natural number is a rational number. And irrational means the numbers which cannot be written in p by q form. Okay, so that already you know about real numbers. So here in your class 10 we are going to learn mainly fundamental theorem of arithmetic. And here in our textbook Euclid division lemma also they mentioned, but the problems are not there basing on Euclid division lemma in our textbook. Okay, in Cbse textbook there are some problems, but we don't have any problem. Okay, but in the introduction they mention Euclid division lemma. Euclid division lemma. Okay, and this, but no problems are given basing on this. Euclid division lemma is nothing but a division algorithm or reminder theorem in your 9th class is there, no? So for suppose a number a is there, we are dividing with b, this is quotient and remainder will be there, no? So a is equals to bq plus r. This is Euclid division lemma, but no, there are no problems basing on this rule. Okay, and fundamental theorem of arithmetic here, every composite number can be expressed as a product of primes, and that is unique whatever may be the order. That is fundamental theorem of arithmetic. Okay, we will learn about this. So fundamental theorem of arithmetic, every composite number can be expressed as a product of primes, and this factorization is unique apart from the order in which prime factorization occur. For suppose you know composite numbers and prime numbers, right? Prime number means the number which have only the numbers which are divisible by 1 and itself. Which are divisible by 1 and itself. That means the numbers have only two factors. What are those two factors? 1 and itself. Okay, and composite number means the numbers which have more than two factors. Okay, more than 2 factors, that means other than 1 and itself also exist. So those numbers are called composite. So prime numbers means 2, 3, 5, 7, 11, 13. Only divisible by 1 and the number itself, right? So here 4, 6. 4 is divisible by 1, 4 is divisible by 2 and 4 is divisible by 4. Okay, greater than 2 factors are there now. And coming to 6 also, 6 is divisible by 1, 6 is divisible by 2, 6 is divisible by 3 and divisible by 6 also. So greater than 2 factors, more than 2 factors are there now. So these numbers are called composite numbers. So this fundamental theorem of arithmetic is explaining every composite number can be expressed as a product of primes. For example, 6 we are taking, we can write 2 into 3, product of primes. Okay, another composite 8. So 2 into 2 into 2, 2 2 is 4, 4 2 is 8. So like this we can express any composite number can be expressed or factorized as a product of primes. So this is the fundamental theorem of arithmetic. So here in our textbook you see this box, an equivalent version of theorem, here not 1.2, actually it's 1.1, was probably first recorded as proposition 14 book 9 in Euclid's Elements, before it came to be known as the fundamental theorem of arithmetic. Okay, so before fundamental theorem of arithmetic only it is there in the Euclid book, they are telling. However, the first correct proof was given by Carl Friedrich Gauss in his Disequations Arithmetica. Okay, so before Euclid, Carl Friedrich Gauss gave the proof of this fundamental theorem of arithmetic. Okay, and here most important point, Carl Friedrich Gauss is often referred to as the Prince of Mathematicians. So Carl Friedrich Gauss is known as Prince of Mathematicians and is considered one of the 3 greatest mathematicians of all time, along with Archimedes and Newton. He has made fundamental contributions to both mathematics and science. Okay. See example 1. Consider the number 4 power n, where n is a natural number. Check whether there is any value of n for which 4 power n ends with the digit 0. Okay, so here the question, we have to check whether this 4 power n ends with 0 or not. Any number to end with 0, it must be divisible by 5. Okay, if you see 4 power n, that means 4 power 1, 4 power 2, 4 power 3, like that only, na? N is any positive number they are telling. So it's 4, 16 and it is 64. So no number is divisible by 5. Okay, all these numbers are not divisible by 5. Okay, to divisible with 5, there must be 0 or 5, right? So 4, how can we write? Prime factorization 2 into 2 whole power n, 4 power n means. So there is no 5 in this prime factorization of 4 power n. So it cannot end with 0. Okay, very simple. You may feel little confusion. Again, any number to end with 0, okay, it must be divisible by 5. To get divisible by 5, the number must contain 0 or 5 in the units place. That is only divisibility rule. Okay, but here coming to 4 power n, there is no 5 in the prime factorization, so it is not divisible by 5. That means it is not going to end with 0 for any value of n. So same we will write here. So if the number 4 power n ends with digit 0, then it should be divisible by 5. Any number with 0 or 5 in units place is divisible by 5. This is divisibility rule. Prime factorization of 4 power n, 2 into 2 whole power n. So the prime factorization of 4 power n does not contain 5. Okay, if 5 is there, then it is it is going to end with 0, right? So therefore it is clear that for any value of n, 4 power n is not divisible by 5. And finally, it is not divisible by 5 means it is not going to end with 0 also. So therefore 4 power n cannot end with digit 0 for any natural number n. Example 2. Find LCM and HCF of 6 and 20 by prime factorization method. So first write the given number as a product of prime factors. 6, 2 3s, right? So 2 into 3 and 20. Again, first prime number 2 only, na? 2 10s, 2 5s. So here 2 into 5. So first LCM. Students, here very easily you can remember about this formula. LCM means least common multiple, right? LCM means least common multiple. So here formula is in opposite. Okay, product of the greatest power of each prime factor. Least opposite is greatest, right? Greatest or highest. So product of greatest power of each prime factor. Okay, so it's 2 power 1 into 3, 2 square into 5. So here product of greatest power of each prime factor involved. Okay, so here 2 and what is the greatest power? 2 square and 3 power 1, 3, that is the greatest, and 5. So what is LCM? Product of greatest power of each prime factor involved. Okay, so 2 square 4, 4 5s are 20, 23 is 60. So 60 is the LCM. Okay, so coming to HCF. HCF means highest, right? Highest common multiple. Highest common multiple. So here also you can remember in opposite way. Highest opposite smallest. What is this? Smallest. And smallest and common power here. Okay, product of the smallest power of each common prime factor. Product of smallest power of each common prime factor. For HCF common. So here what is the common prime factor? 2 only, and this is the smallest power. So 2. HCF what? 2 here. Okay, and LCM of 6 and 20 is 60, and HCF of 6 and 20 equals to 2. So in this way we can find LCM and HCF by using prime factorization method. Example 3. Find the HCF of 96 and 404 by prime factorization method. Hence find their LCM. Okay, so first here we have to find HCF. They are mentioning prime factorization method. So first take 96. So what is the first prime number? 2. So 2 4s are 8. Students, this is common division only. So here 96 common division, 2 4s are 8, and after subtracting 1, and this will come down now. So in the same way here 2 8s are 16, like this. Okay, again 2 2s, 2 4s, again 2 1s, 2 2s, again 2 6, so again 2 3s. Okay, so like this. So 96 can be written as 2 5 times into 3. That means 2 power 5 into 3. Okay, and next number 404. So 404. First prime number 2 only, na? So 2 2s, 0, 2 2s. Again 2 1s, 0, 2 1s. Okay. So here 101 is a prime number. Okay, 101 is the least 3-digit prime number. So 2 into 101. Okay, so first circle the common factors. 2 2, again 2 2. First we have to find HCF now. So HCF, what is HCF? Highest na? So opposite. Okay, opposite, that means product of the smallest power of each common factor. So common and smallest power. So 2 into 2, that is 2 square. So HCF is 4. Product of the smallest power of each common factor. Okay. So actually, see, this is 2 square 1, common factor 2, and what is the smallest power? 2 square. So that is the HCF. And from this we have to hence find their LCM. So we know LCM into HCF is equals to product of the numbers. Product of numbers. So from this LCM is equals to product of numbers. Here in LHS, HCF is in multiplication. So after transposing, it comes under division. HCF. So product of numbers 96 into 404 by their HCF 4. So cancel 4 ones, 0, 4 ones. So 96 into 101. Simply this 9696. So this is the LCM of 96 and 404. Okay. So in this way we can solve. Example 4. Find HCF and LCM of 6, 72, 120 using prime factorization method. So here 3 numbers are given. So first 6. 6 means 2 3s. Okay. Prime factors 2 into 3. Next 72. So here in the units place 2 is there now. So it is divisible by 2. First prime number 2 3s are 6, 2 6 are 12. Again 2 1s, 2 1 will be there now. It is 16. 2 8s are 16. 2 9s are 18. 3 3s are 9. Next prime number. Okay. So 3 2s and 2 3s. So 2 cube into 3 square. And here this one 2 power n, 1 into 3 power n. So next third number 120. So right here 120, 2 6 are 12 and 0. 2 30s, 2 15s and 3 5s. Very small numbers, no? So it's very easy. So here 3 2s and 3 into 5. So it's 2 cube into 3 into 5. Okay. So first HCF. HCF of 6, 72, 120 is equal to. So what is HCF? Highest. So I told you to remember in opposite. Product of the smallest power of each common factor. Smallest power of each common factor. First of all, common factor is 2, right? That is smallest power 2. And another common factor 3. 3 is there na, in the 6, 72 and 120. So smallest only 3 power 1. So it is 6. Okay. Simply the common factor ma. Okay. And 3 is in common. So that is 2 into 3, 6. And next LCM of 6, 72, 120. LCM means least common multiple. So in the opposite way, product of the greatest power of each prime factor involved. Greatest power of each prime factor involved. There is no common. Each prime factor. So greatest among these two, 2 cube. In 3 is greatest, 3 square. 3 square na? And 5 is there. So 2 cube 8, 3 square 9 and 5. So 8 5s are 40 into 9. 4 9s are 36. So 40 9s are 360. So LCM is equals to 360. So these are the 4 examples and introduction. Okay. And another most important thing, we told you HCF into LCM is equals to product of 2 numbers. Okay, so that is only for 2 numbers. Okay, and here 3 numbers are given na? So HCF of 3 numbers into LCM of 3 numbers is not equals to product of those 3 numbers. Okay, it is not right. Only it is right in the case of 2 numbers. Okay students, so this is the introduction and example problems. I hope you understand this. So students, please share with your friends and please like this video and please follow the channel for all the chapter explanation. Thank you for watching.